And welcome to our continuing exploits with AutoGen as we head into day 3 of week 5 and talk about AutoGen Core. So just to remind you, this is where AutoGen Core sits in the scheme of things. It is the kind of base, it is the basis of AutoGen Agent Chat, and it's the fundamental infrastructure behind it all, which is exciting. One other thing I wanted to point out while we're on this screen is that you might have heard of something called Microsoft Semantic Kernel. And you might be wondering, where does Semantic Kernel fit into all this picture? Isn't that an agentic framework as well? And what's that got to do with all of these? Well, the answer is Semantic Kernel is a bit different. It is more akin to something like LangChain. Semantic Kernel is a reasonably heavyweight glue code that does things like wrapping calls to LLMs. It handles stuff like memory. It handles stuff like tool calling with its own sort of framework around that and its own name. It calls them plugins and everything else, structured outputs and so on. So it's very much analogous to LangChain. It even has its own like prompt templating framework as well for building templates and populating templates of prompts. So it's different. There is, of course, overlap. You can use Semantic Kernel to be managing things like tools and agent calls, and there is some agent functionality there. So there is some overlap that Microsoft's very aware of, but they would see it as a pretty different kind of offering. AutoGen is a high level, very much more agent focused. All of this is very much focused only exclusively on the world of building autonomous agentic applications, where Semantic Kernel is more about stitching together calls to LLMs, generally for business purposes. Well, I hope that gives you some context there and explains why we're not looking at Semantic Kernel for this course, because that's more something you might do alongside looking at LangChain or something like that. Okay, onwards. So what is AutoGen Core exactly? Well, here's a story. So it is an agent interaction framework. That is how they describe it, and that's what it is. It is agnostic. It doesn't care about the platform, the product you're using to actually code your agents, the actual abstraction you have around agents. You could be just calling LLMs directly, or you could be using an abstraction around them, some framework, some glue. Either way, doesn't matter to AutoGen Core. It is just about agents interacting. If you wish to use the agent chat framework as your agent abstraction, that works well, and that's what we'll do. And they're clearly somewhat designed for each other. And we know that agent chat is built on top of a AutoGen Core, so that makes sense. But it doesn't require it. A bit like LangGraph doesn't require LangChain, but it helps if you use LangChain because there's lots of similar kinds of thinking there. So in some ways, it is actually similar positioning to LangGraph. LangGraph, you could argue, is also about interactions between agents, although very much thinking of things in terms of the graph of operations and dependencies, the node graph that now we know so well. But similarly, you could argue AutoGen Core is about interactions between operations. That's what it thinks about. And similar to LangGraph, AutoGen Core doesn't care about how you've implemented your agents. So there's definitely some parallels there. But the big difference is that LangGraph is all about this idea of robustness and repeatability, this idea of being able to replay back in time. Everything that's been built around LangGraph is for that purpose, you can tell. Whereas it seems to me that the driving force behind AutoGen Core is more about building a kind of environment where agents can do things like interact with each other, where agents that could be in very distributed places, they could be all over the place, and they could be very diverse. They could be written in different languages. They could use different abstractions, but one could be written in JavaScript and one in Python. It could be from all sorts of different shapes and sizes, and they're all able to play nicely in the AutoGen Core world, because AutoGen Core takes care of the interactions between them. It takes care of creating them, and it takes care of messages between them. So that's the kind of thesis behind AutoGen Core. And arguably LangGraph also thinks about that kind of thing. I think it's just a different emphasis. This is the real emphasis of AutoGen Core. It's about the interactions and supporting diverse interactions. And welcome to our continuing exploits with AutoGen as we head into day 3 of week 5 and talk about AutoGen Core. So just to remind you, this is where AutoGen Core sits in the scheme of things. It is the kind of base, it is the basis of AutoGen Agent Chat, and it's the fundamental infrastructure behind it all, which is exciting. One other thing I wanted to point out while we're on this screen is that you might have heard of something called Microsoft Semantic Kernel. And you might be wondering, where does Semantic Kernel fit into all this picture? Isn't that an agentic framework as well? And what's that got to do with all of these? Well, the answer is Semantic Kernel is a bit different. It is more akin to something like LangChain. Semantic Kernel is a reasonably heavyweight glue code that does things like wrapping calls to LLMs. It handles stuff like memory. It handles stuff like tool calling with its own sort of framework around that and its own name. It calls them plugins and everything else, structured outputs and so on. So it's very much analogous to LangChain. It even has its own like prompt templating framework as well for building templates and populating templates of prompts. So it's different. There is, of course, overlap. You can use Semantic Kernel to be managing things like tools and agent calls, and there is some agent functionality there. So there is some overlap that Microsoft's very aware of, but they would see it as a pretty different kind of offering. AutoGen is a high level, very much more agent focused. All of this is very much focused only exclusively on the world of building autonomous agentic applications, where Semantic Kernel is more about stitching together calls to LLMs generally for business purposes. Well, I hope that gives you some context there and explains why we're not looking at Semantic Kernel for this course, because that's more something you might do alongside looking at LangChain or something like that. Okay, onwards. So what is AutoGen Core exactly? Well, here's a story. So it is an agent interaction framework. That is how they describe it, and that's what it is. It is agnostic. It doesn't care about the platform, the product you're using to actually code your agents, the actual abstraction you have around agents. You could be just calling LLMs directly, or you could be using an abstraction around them, some framework, some glue. Either way, doesn't matter to AutoGen Core. It is just about agents interacting. If you wish to use the agent chat framework as your agent abstraction, that works well, and that's what we'll do. And they're clearly somewhat designed for each other. And we know that agent chat is built on top of AutoGen Core, so that makes sense. But it doesn't require it. A bit like LangGraph doesn't require LangChain, but it helps if you use LangChain because there's lots of similar kinds of thinking there. So in some ways, it is actually similar positioning to LangGraph. LangGraph, you could argue, is also about interactions between agents, although very much thinking of things in terms of the graph of operations and dependencies, the node graph that now we know so well. But similarly, you could argue AutoGen Core is about interactions between operations. That's what it thinks about. And similar to LangGraph, AutoGen Core doesn't care about how you've implemented your agents. So there's definitely some parallels there. But the big difference is that LangGraph is all about this idea of robustness and repeatability, this idea of being able to replay back in time. Everything that's been built around LangGraph is for that purpose, you can tell. Whereas it seems to me that the driving force behind AutoGen Core is more about building a kind of environment where agents can do things like interact with each other, where agents that could be in very distributed places, they could be all over the place, and they could be very diverse. They could be written in different languages. They could use different abstractions, but one could be written in JavaScript and one in Python. It could be from all sorts of different shapes and sizes, and they're all able to play nicely in the AutoGen Core world, because AutoGen Core takes care of the interactions between them. It takes care of creating them, and it takes care of messages between them. So that's the kind of thesis behind AutoGen Core. And arguably LangGraph also thinks about that kind of thing. I think it's just a different emphasis. This is the real emphasis of AutoGen Core. It's about the interactions and supporting diverse interactions. So here's the core idea behind AutoGen Core. And I've already alluded to this idea. And it's that it's all about decoupling the logic of an agent, what it actually does, from how messages get delivered to it, from the interplay between them. The framework deals with creating and communicating. It deals with creating agents, the whole life cycle of an agent, and the messages, the communication between them. And the agents themselves, or us as the people coding the agents, we're responsible for the logic. It's not the mandate of AutoGen Core. It just deals with letting them play. And there's two ways that it lets them play, two types of runtime. The runtime is the kind of AutoGen Core world in which agents interact. And the two types, one of them is called standalone, which basically essentially means it sort of runs on your box in a simple way. And the other, distributed, is that it runs in a way that could allow remote agents to interact with each other. So these are the two kinds, and you code them both a bit differently. We are going to look at the standalone one today, and we're going to go to the distributed one tomorrow. And look, I have to tell you, I'm only going to do this at a high level. We're going to breeze through this quite quickly, and the examples will be somewhat superficial. And there's a reason for this. I feel like we've done enough detail on lots of frameworks and actually building agents. I'm not sure how applicable this is going to be to your use case. I think it's good for you to get a feel for it and to get a good sense of how this is positioned and where it might be useful. And that's my goal, give you a flavor, give you that kind of sense of where it fits in the ecosystem. And if it's relevant for you, if this is something that you do want to put into practice, then you should carry out more R&D and work on this a bit more yourself. And I'll give you plenty of starting points for that. But I'm not going to go so deep into this as some of the other frameworks, as like LangGraph last time, but enough so you get a feel for it. And then we move on, because I know you're anxious to get to MCP. All right, let's do a lab. So here we are in good old Cursor, going to the 5th folder for AutoGen, and we are going to lab 3 AutoGen Core. So this is where we begin. There's, as I say, something a little different. This is going to be different to anything we've looked at before. Okay, so there's a bunch of imports, including a good old load.env. Let me just restart this, make sure it's fresh. Do the load.env. All right, so the first thing we do is we define our own object, which is going to be used for passing information around the place. Our own message object. And it is a type of, I don't know if this is required, but a data class means it's a class that's not going to have any methods. All it is something that holds data. And that makes sense, because the message is not going to be something with functionality. It's going to be used to transport information between our agents. And in a way, like, doing this is sort of analogous to when we were in LangGraph. We started by defining a state. LangGraph is a state machine. It's very focused on what is the state and making sure that that's something that you can move backwards and forwards in. And it's interesting that, AutoGen Core's fundamental idea is all about messaging. And so the thing that you start by defining is your message. And in our case, we're going to have a very simple one that just has one field, which is content, which is a string. But you can experiment with what you pass between your agents being something much more sophisticated with all sorts of different bits of information. So there we have it. We have a message with a string, and that's all the message we'll be using for today. So now we get to define our agent in AutoGen Core. And it's important to bear in mind that the agent that we're about to create in AutoGen Core is different to the agent that we just created in Agent Chat. It's difficult. It's like a tongue twister to say all of this. It's hard to keep your mind on it. You're like, what? How is it different? Well, look, the agent that you define in AutoGen Core is just like a wrapper. It's like saying, this is a thing that can be messaged. It can be created, it can be managed, it can be referred to, and it can be messaged. But what you do with this is your responsibility, and you're going to have to delegate to something. But this is like a management object, if you will, a management object which you're going to use, and it has, amongst other things, it has an agent ID, and every agent has a unique ID, and that ID has two parts to it, a type and a key. So every single agent has a type and a key, and that combination of type and key is then unique and can uniquely identify it. So if you imagine when we in the future look at a distributed runtime, in that runtime there could be agents from all over the world collaborating in this distributed runtime, but every one of them will have a unique type plus ID that identifies it precisely, and any agent will be able to talk to another one if it knows its name and its ID. Its key and its ID. So this gives you a sort of good sense of the fabric of it, and that an agent class that you make is not actually an LLM. It's not an AutoGen agent chat agent. It's just this management holder object, something which has a type and a key. So here is our first AutoGen core agent. It's called simple agent, as you will see. It is a subclass of something called rooted agent, which is the thing that you have as your parent, as your superclass. And it only has two methods. One of them is the init, the constructor, and all it does is it calls its parent, passing in its name simple. That's all it does. Then it has another method called onMyMessage, which is an async. So it's a coroutine. It's an async method. It is an async coroutine. It is a coroutine. And it's decorated with message handler. And that's what matters. Any method that you decorate with message handler means that potentially this is something that will receive messages. And AutoGen Core handles the fact that you'll be able to register this, and a runtime is going to manage this. And if someone sends a message to something with my name and my ID, then it's going to end up here. At least it's going to end up here if what they dispatch is a message of this class. So this is a bit of a pro thing, but you can have multiple different classes and you can use that to be able to handle different types of message. This may be more detail than you need, but you could, for example, have a text message and an image message and have two separate handlers. And just by virtue of the different signatures, the different method signatures, AutoGen Core will automatically dispatch the right message to the right method, the right coroutine. That's what it does. It's all about dispatching messages properly. And so this simple agent is going to return it's going to receive a message and it's going to return a message. It is, now that I said it is a bit like this idea that in LangGraph we took in our nodes, took a state and returned a state. But this is just like a parallel thing, but it's all about messages. It receives a message and it returns a message. And it's an async. It's a coroutine, as I said. So it receives the message, and this one isn't going to do anything with the message it receives. There's no LLM. There's nothing here. It simply returns a message which has this is, and gives my ID and my key. So it's sort of identifying itself. It's saying this is blah blah blah. You said, and I'm gonna replay back what the person said. So I do use this. You said blah blah blah, and I disagree. So that is simple agent. It's maybe I should call it a disagreeable agent. That's what it does. There's no LLM. There's no AI involved in this at all. It's it's just a piece of code. But that doesn't matter to AutoGen Core. AutoGen Core just cares about the handling of messages. Okay, so now we get to the meat of AutoGen Core. We are going to create a runtime. A single-threaded agent runtime, it's called, which is a standalone runtime running on my computer, which, as it says, will handle agents in a single-threaded way. And the first thing that we're going to do is register. We call register on the agent itself to say, I want you to register yourself with this runtime. Now, this isn't creating an agent. This is just saying you are a type of agent, and I want you to tell the runtime that you are a type of agent that can be spawned, you can be created. And you are a type of agent of type simple agent. That's going to be your type. And this thing here, this is a function which can generate new versions of you. It can instantiate you. It is a factory. And you pass that in as well. And so I will do this. It's now created a runtime, and it's created a type of agent called a simple agent. We haven't actually yet built any of these. We haven't instantiated one, but as a type of agent, it is now a known thing to our runtime. Our runtime knows that there are such things as simple agents. And we're now going to start our runtime. It is now running. It is a proper runtime. And now we are going to we're going to first of all create an agent ID object to identify an agent, and we'll do this properly. We'll say agent ID equals that. That is an ID that would identify this, and we are going to say that we want the default agent because that will then we'll make sure that we have an agent created, and then we are going to send a message to we're going to send a message to the agent, which is called simple agent, the default ID, and we're going to send a message, well, hi there, to it, and then we will print whatever comes back. So any ideas what's going to come back, I wonder? It replied, this is simple agent dash default. So it's simple agent is its type, which is the same one we registered, and default is the ID. And it said, you said, well, hi there, and I disagree. Charming. And that's it. So there is a demo of AutoGen Core, and that's what AutoGen Core does. And putting in agent functionality, like having code in there that calls LLMs, that's your job or my job. That's not AutoGen Core's job. What it's there to do is to handle the passing of messages around by looking things up based on their type and their ID, and that's what it does. So now I'll show you one which has an LLM behind it, but it shouldn't be any surprise to you because it's just the same infrastructure. The fact that we're calling an LLM is almost of no consequence to the AutoGen Core framework. So what we're going to do is we're going to make a slightly more interesting one called My LLM Agent, still a subclass of rooted agent. And we're going to use a proper LLM, and we could just call OpenAI directly using OpenAI .chat.completions.create. We could just call the Python client library, but we can also use AutoGen agent chat, and we might as well since it's AutoGen week. So this is the same kind of thing, a subclass of rooted agent. There's going to be two functions again, init and handle my message. So the init just calls the superclass, but it then creates a model client. But this could be doing anything, but this is the AutoGen agent chat way. We're going to create one of these things, a GPT-4o mini model client, and we're going to set a field called _delegate, which we're just sort of holding on to. This is the underlying, this is what our agent object is going to delegate to when it actually needs some code, an LLM to run. And we could have anything we want. We could reply back with random things, or we could create an instance of assistant agent, and that's what we're going to do. And that's where we put in, if you remember, when you create an assistant agent, there's the name of the agent and there's the model client, and there it is. And as a result, in _delegate, underscore often used to show sort of like private, secret variables that other people shouldn't know about, like private in the Java world. So this is being set to an assistant agent. So now we just have to write our message handler. And as I say, it can be called anything you like. I'm calling it handle my message type. And that's really to sort of draw your attention to the fact that what matters is what type of object comes in the message field, because AutoGen Core will automatically route messages to agents that should receive them based on the finding a handler that looks for a message of that type. That's how it works. That's the clever routing that it does. And by the way, you can send a message direct to an agent, which is what we're doing right now, but it also has a whole kind of pub sub thing there where you can subscribe to topics and you can publish out messages to lots of agents that are all interested in one particular topic. So the whole process of dispatching messages to the right agent and then calling the right handler, that's the clever stuff. That's what it does well, and why we use a framework like this rather than coding it ourselves. But for some of these examples, it's pretty trivial, so we could equally code it ourselves. But you can imagine that this is done in a way that can be scaled and distributed. So anyways, handle my message type as long as a message is sent to this agent with the ID and type, and that the object that's sent is of this type, it will arrive at this function. And I'm going to say that I received a message and print the content. Then I'm going to, now this is confusing. This object here, text message, looks subtly different to this object here, message. Do you know what's going on here? This text message is text message from the AutoGen. It's this thing here. It's the agent chat messages, the text message, the same thing we were using yesterday and the day before when we were interacting with agent chat agents. So this is a AutoGen agent chat message, which can be a bit confusing, and you might, there are ways you could get around that by giving it a different. You can say like as agent chat text message if you wanted to like make it so the code is a little bit clearer and you're distinguishing between the AutoGen core and the AutoGen agent chat. All right. Anyways, so sorry, back we go. So we create the sort of text message that you need for AutoGen agent chat, passing in the content of our message, and the source is user. And this is the on message that we call in agent chat land with this text message and the cancellation token, if you remember that thing. And then we get back the content. We say that that was the reply, and we return a new instance of message, of our message, with the content being that reply. I hope you followed all that, or at least got enough of an idea of it. Let's give this a shot. Let's create a new runtime, a single threaded agent runtime, a standalone runtime. We're going to register two agents, the simple agent and the LLM agent, the new one. Simple agent isn't really an LLM at all. It just disagrees with whatever it's told. An LLM agent is actually going to dispatch through this underscore delegate down to a true GPT-4o mini. So we're going to start the runtime. Then we are going to send a message, hi there, to the real agent. And with whatever it replies, we're going to send that. We're going to forward that on to the other agent, to the simple agent, and see what comes out there. So the LLM agent received, hi there, and it said, hello, how can I assist you today? A classic GPT-4o mini response. And the simple agent said, this is simple agent default. You said, hello, how can I assist you today? And I disagree. And there you go. And with that, we will stop this pantomime. Did I just say that I'd stop this pantomime? Well, I take that back. We'll do the pantomime one more time. I've just added in another response from the nice LLM agent. So I'm going to have the LLM agent respond to hi there. I'm going to have the disagreeable agent disagree, and then I'll put it back to GPT-4o mini to see how it handles the disagreement. Let's see how this little conversation goes. Hi there. Hello, how can I assist you today? You said, hello, how can I assist you today? And I disagree. And then GPT-4o mini says, I appreciate your feedback. How would you prefer I greet you or assist you? So if you want to be cruel, you can keep this going and just have it continually disagreeing and see how GPT-4o mini handles that. And once you've had your fun, then you should do this. This stops the runtime and then closes the runtime, which the AutoGen core people insist that we do before we start another. So we will do that and be good to it. Okay, but for one more example, and I'm afraid this time we're not going to have sort of true commercial examples because I think this is just one to show the platform at work, and you can take this away and figure out what you'd like to do with it. But for this example, we're going to play rock, paper, scissors between a few agents to show, because I just want to illustrate the fact that this collaboration, this interaction is what it's all about. So very simply, we have a player one agent that is a subclass of rooted agent. And it has a OpenAI chat completion client as its underscore delegate. It has an assistant agent that uses that as the model client. And then it has handle my message type that takes messages and returns the response. So this is a super vanilla kind of LLM routing that will just simply respond to the message that it's given in the message object. Okay, we got a player 2, which is exactly the same thing, but with one tiny difference. Can you spot it? Can you spot the difference between those two? Well, the difference is that this has Ollama chat completion client instead of OpenAI chat completion client. So we're going to use Ollama. We're going to use a local model, and we are going to see which model that we pick for this one. We're going to pick Llama 3.2, the 3 billion variant of Llama 3.2. So these are our couple of agents. And now we're going to have a third agent, and this is going to be rock, paper, scissors agent. So this one is going to have a little bit more of it's going to have an instruction. You are playing rock, paper, scissors. First of all, it comes up with this instruction. You're playing rock, paper, scissors. Respond only with the one word, one of the following: rock, paper, or scissors. And it puts that together into a message. It looks up the default ID, the default key for player 1, that type. And it looks up the default for player 2, that type. And it's looking them up, and it then, as part of handling its message, it dispatches off a message to these other agents. So it's just choosing it's not choosing, it's like coded here, but it is sending those messages off. And with what comes back with the result, it then puts together a little piece of text called judgment, which says you are playing a game rock, paper, scissors. The players have made these choices. Sorry, you're judging a game rock, paper, scissors. Players have made these choices. And then it ends with who wins, question mark, after slipping in the player 1's choice and player 2's choice. And then that gets dispatched off to my model, which is GPT-4o Mini, and we return the response. So just to summarize, we have a total of 3 agents that we've defined here, 3 of these like agent managers, these agent wrappers. They're not real agents. They delegate to real agents. One is called player 1, and it delegates to OpenAI, to GPT-4o Mini. One is called player 2, and it delegates to Llama 3.2. And they don't have any prompts. They just do whatever instructions they're told. And then there's one called judge, and judge very clearly sends an instruction to each of player 1 and 2 saying pick rock or paper or scissors. And then with what comes back, it then judges them and returns the outcome. So there we have a simple setup for a game of rock, paper, scissors. And you can, of course, make this something more interesting. You can have it be something that's entertaining, or you can have it be something that's serious, it's commercial. Like when we're thinking next time in week 6, we're going to be building like a financial trading setup. You could imagine this could be something where different agents can interact and can argue about something like whether or not a particular equity is good investment or a poor investment. You can imagine that's the kind of interactions that could be going on. So this, whilst we're using this here for a superficial exercise, there's plenty of ways you could imagine. Anytime when you'd want a sort of autonomy and the ability for different agents to be interacting, you could build that kind of commercial logic into this kind of framework. And that is what AutoGen Core is for. Not for playing rock, paper, scissors. But anyways, rock, paper, scissors is the cards you've been dealt, and so we might as well play them. Let's give it a shot. And quite simply, we create a single threaded agent runtime, which is the simple kind of like local runtime. We register player 1, we register player 2, and give it the ability to instantiate players 1 and 2. And then we register the judge, the rock, paper, scissors, and have everything ready to go, and we start our runtime. So we've registered everything, and this is where we do it. We are going to find our rock, paper, scissors default agent. We are going to say go and set it going, and let's see what happens. Off it runs, agents are talking, stuff is happening, and there we go. Player 1 said rock, player 2 said scissors, player 1 wins because rock beats scissors, done. And there you have it. There you have agents being organized and interacting, and agents being discovered. The rock, paper, scissors agent discovered these 2 agents by name, by identifying them through the sending a message through the runtime, and we saw agents interacting in a game of rock, paper, scissors and being judged, managed by AutoGen Core. And so again, there are these two types, standalone and distributed. Today we did standalone, tomorrow we'll do distributed. And I just want to stress again that this is to give you a flavor. It's not necessarily as essential for the building of agents that we're doing mostly on this course, but it's good for you to get this insight and to see it and compare it with the other offerings out there. So with that wraps up day 3. And as I say, tomorrow we get to distributed. I'll see you then.